All right, so let's go over some homeworks. That's basically going to be the review for the quiz. It's just going over the homework. So we're going to start with 3-2 because that's what I just assigned. And this is like part B, right? 28 to 33. See, I did them right there. See that nicely? So I did the work too. Let's do 29, okay? I said we were going to talk about that, so let's do that. And let me grab a graph. I will have graph on the quiz, all right? So you can use the graph and you can be a little bit accurate. So that'll be nice. Now again, like I said, I haven't made the quiz up yet. But I'm thinking, I don't know if first of all, I don't know if you have enough time to do all 10 questions in one class period. So I may only have 5 questions on the quiz. Again, I haven't made it up, but I think I might do that. Is that all right? Because, I don't know. We'll see. I'll see if there's enough for us to do. All right, so let's take a look at number 29. So number 29 says, I don't know if it says sketch the graph or not, but that's basically what we're doing. We're sketching a graph. Now, we've seen this. I did this on the Desmos program. I showed you what the answer was yesterday, right? Took a screenshot of the book and put it up there. But let's talk about how to do this. And Abby brought up a great point. I kind of know where the first point goes, but I'm not sure what to do after that, all right? So that's what we're going to try to do today. So let's take a look at it. First of all, forget the absolute value for right now, okay? Don't forget it for the whole problem. But for right now, forget the absolute value. What would this basically look like? Let's do a super easy sketch right here. Forget the absolute value. If it was x squared minus 4, first of all, what does that minus 4 tell you you're going to do? You're going to go down 4 on the y-intercept. That's right, okay? So you'll put a point right there. Now, what does an x squared graph look like? Give me a word. Do you remember what the word is for the shape of it? Starts with a P? It's a parabola, right. Okay, what's a parabola look like? So like a U. Yeah, okay. It goes like this, and it goes like that. That's basically what a parabola looks like. Everybody with me on that? All right. So we're going to graph it right here. Let's do that. Now, what I'm going to do, though, if you remember, because I've talked about this, I've explained this to you verbally. I just don't think we've seen it right here. We saw it on the Desmos program, but we haven't done it. So it is an absolute value, though, isn't it? All right. If it wasn't, it would look just like that. That's the way the graph would look. All right. But it is an absolute value, which means the y values cannot be negative. Does that make sense? All right. Because absolute value means it can't be negative. So that means all this stuff, all that stuff right there cannot be below the x-axis. Where has it got to be? It's got to be positive, right? So instead of 0, negative 4, what would it be? 0, positive 4. Everybody see that? So instead of this being whatever it is, negative, instead of that, what would it be? It would be, I probably didn't go up high enough, but you get the idea. So it would go like this. I'm going to be a little bit more specific on here, okay? So just bear with me. And again, this thing just keeps on going like that. This keeps on going like that. So really, this is your graph right here, just the stuff above the x-axis, all right? Now, the question is, and it's a great question, that's what we're going to do today, is like, how far over do I go? Like, where is it hitting right here? Agreed? All right, that's what you want to try to figure out. So that's what we're going to do. All right, so that's basically what it's going to look like, except for the stuff there is on the bottom. But let's do this. So I'll do this first part in yellow. So if it didn't have the absolute value, where would we go? 1, 2, 3, 4, correct? Okay, now, how much does it stretch out? That's our thing. Well, what you can do is this. Make a little table. Now, you don't have to put like a whole bunch of points on there. Just put some key points on there. This is right in the middle. So let's just pick a point that's what? Just 1 over, all right? So what's 1 over from 0? It's 1, right? So let's put a 1 in there. And then on the other side, it's just going to be a mirror image. So do I even have to put a negative 1 in there? Nope, because wherever I go over on the 1, if I go over negative 1, I'm going to go to the same spot because it's a mirror image. Does that make sense? Okay. What if I go over 2? How far do I go? Well, let's plug it in. Well, let's do the 1 first. Let's do the 1, then the 2. All right. You know what the 0 is going to do for you, don't you? What's the 0? 0 squared minus 4 is negative 4. So if it didn't have the absolute value, we'd put a dot here at negative 4. But it does have absolute value, right? So where are we going to put the dot? At positive 4. 1, 2, 3, 4. You with me on that? So that dot just shows you where it would be if you didn't have the absolute value. But you do have absolute value, so it's going to be right here. There's a reason I put that dot. I'm going to show you. I'll show you. Hopefully it'll make sense. Maybe it'll make it a little easier to graph. Let's put a 1 in here. So 1 squared is 1 minus 4 is negative 3, correct? All right. If it didn't have the absolute value, what would you do? You'd go over 1 and down 3 right there. Agreed? Now, without putting a negative 1 in there, what would it be if you put a negative 1? It'd be a mirror image. It would be right there, wouldn't it? Let's put one more in there just for fun. Let's put a 2 in there. All right, so if I put a 2 in for this, 2 squared is what? 4 minus 4 is 0. So if I put a 2 in there, it's going to be right there. And then a mirror image on the other side. If I put a negative 2, it's going to be right there. So watch. This is what it would look like if what? I've said this like 3 times already. If you didn't have an absolute value, right? Okay, so it would go like this. And it would go like that. All right, and you can put other numbers in there. If you wanted to put a 3 in for this, what's that? 3 squared is 9 minus 4 is 5. Square root of 5 is like 2 point something. All right, so anyway, it just kind of keeps on going like this. Doesn't have to be perfect. Keeps on going like this. But what's the problem, though, with this? That's right. This is all negative, right? So you're not going to have any negative values. So what do we do here? Instead of going over 1 and down 3, what's it going to do? Go over 1 and up 3. You see that? And then over 2, 0, right? So what would it look like? Let's do this in a different color. So it would look like this. And then should be a nice little curve. And all this stuff is not going to be in there. All right? Whoops. So let's put everything in red. So this is going to go like that. And then this is going to go like that. So the stuff in red is your graph. All right? I just put the stuff below because I recognize what a parabola looks like, okay? It's a little bit easier. But then you got to think, wait a minute, I'm in absolute value, so I can't have anything below the x-axis because that means the y's would be negative. I can't have a negative y or a negative g of x. Does that make sense? So I cannot include all that. But what happens? I could put a couple points in there just to see where it goes. If I put a 1 in there, I go up to 3. If I put a 2 in there, I'm at 0. You could put a 4 in there, all right? Put a 4 in there. What's 4 squared? 16. 16 minus 4 is 12. Absolute value is 12. So if I go 1, 2, 3, 4, now I don't have enough room, but it would be like way up here somewhere. You see that? Do I have to put that point in there to be that specific? No. I'm good right here. Really what I'm looking for is I'm looking for that point, I'm looking for that point, and I'm looking for that point. And I'm looking for the shape. Okay? That's really all I'm looking for. Like all those in-betweens, if I miss it a little bit, no big deal. It's just a sketch of a graph. All right? But that's what I'm looking for. I'm looking for down to here, up around like this, and back up like that. Does that help a little bit? That's not too bad, is it? If you understand what a parabola looks like, and that tells you it's a parabola, this tells you it goes down 4 places, so you just draw it like normal. But then you look at it, you say, wait a minute, this is an absolute value, so none of this stuff can exist. All right, so I'll just erase it. I don't really have an eraser on this program to do that, but you get the idea. Okay, enough of that. We okay with that? Any questions on that? Now's the time to ask. Abby, does that help? Like what points you put in? So what I like to do is you basically know what it looks like. You kind of know what it looks like, okay? That x squared means, okay, I'm going to have a parabola. The -4 means it's going to be down here. But then you got to think a little bit more. So you can just put some key points. You don't have to put like 30 points in there to see what this shape looks like. I mean, you could. That's a possibility if you wanted to do that, but it would be silly. Hello? Well, this would have to be specific, okay? This is supposed to be at 4, right? So that should be at 0, 4, okay? And this should be at what? -2, 0, and 2, 0. So those should be specific. But like the shape, it still needs to be this curve. It's upside down parabola, basically, is what that is. Would you agree? It's just this, it's just flipped up. And then this just keeps on going like that. Remember, these are not straight lines. Okay, this little bit right here, so it's got a little bit of a curve to it. Not much, but a little bit of a curve to it, a little bit of curve to it. So that's what it should look like. So your graph should look like this, and then up like that, and then up like that. It's kind of ugly, but you get the idea. Probably a little bit more of a hump than what that looks like. But that's basically what it should be, okay? And you should put the points on there, okay? Right there is at 0, 4. This point is at 2, 0. This point is at -2, 0. So those are the key points that I really would like to see, okay? I mean, if you wanted to put the point 1, 3 in there, you can. That's fine, yep. Well, again, you just pick numbers that, because I'm not even picking numbers at first. Like if I just asked you to graph y equals x squared, okay, you know that it would be here. Look, pick one point to the right, that's 1. What's 1 squared? 1. Pick another point, 2 squared is 4, right? So that's what your graph would look like. It'd look here and look here, right? But we take this thing and the -4 does what to it? Shifts it down 4, 1, 2, 3, 4, okay? So your graph is gonna look like this. But then you look at it and you're like, wait a minute, I got absolute value. So I can't use any of this stuff down here, so I just take it and flip it up. That's how I would look at it, okay? And then again, to see like how much it curves, I mean, why do I know it doesn't curve way out here? Because I picked a point like, I mean, you put a 3 in there if you wanted. I think we talked about that. 3 squared is 9 minus 4 is 5. So if you put a 3, then you're going to go up to 5. So you're just picking numbers that are close, right? Close to the middle. You know it's symmetric, right? You know it looks the same on one side as the other side. So if you pick a point for one side, you don't even have to do the math when you pick the point on the other side. Does that make sense? Because it's going to be in the same spot because it's symmetric. Yes. Yeah, let's do it. 31. Yeah, we can do 31 and 32. I'll tell you what, let's do 32 first. 32 is actually a little easier. Oh, 30 also. 30 also. Gotcha. All right, let's do 30. Yeah, let's do 30, then we'll do 31. Let me copy that graph again. Put it right here. Let's. You know, I kind of doubt I'll put a greatest integer function on the quiz. All right. Yeah, I probably will not do that. Okay, put a greatest integer function. I mean, I can show you how to do it, but maybe we'll wait to the end till, well, we're almost at the end. We got 10 minutes left. Let's do 30. Now, they use all these letters, h of x, g of x. They use q of x, n of x. Okay, you can use any letter you want. Or you could just call it y equals, right? It just means kind of the same thing. Let's see. 1/2. I think, did they put 0.5 or 1/2? They put 0.5. I put 1/2 just because, I don't know, to me, 1/2 just looks better. But yeah, they put 0.5. I just did that for myself. All right, so now, what's this thing going to look like? What family function is this? This is a what kind of function? It's a what? It's a cube function, right? It's a cube function. So what does a cube function look like? If I had y equals x cubed, right, like this, what would that look like? Well, one goes up like this, and then what happens to the other one? It goes down like that. So that's your family of functions, right? That's your parent function, as they call it, all right? So ours is going to kind of look the same, but a little different, just a little bit. What does that minus 1 do for you? It moves it, well, actually, it does a couple things. You'd think it would move, well, it's inside the cube, so it wouldn't move it down. If I had a minus 1 outside of here, it would move it down. Yeah, to the right. But the 1/2 does something weird to it as well, okay? So here's a situation where I kind of know what it's going to look like, right? So I have an idea it's going to look like this. So I'm going to put some points in there. Oops. I'm going to put some points in there. Let's do this in white. I'm doing that in red. All right. So here's my x, here's my y, or h of x, whatever you want to call it. Let's try an easy point. Now it is 1/2 times x. So what do you think a good type of number would be to put in for that, to make it come out kind of nice and even? Yeah, put in a 2, right? Put in an even number, right? Because I'm taking half of it. Would you agree? Yeah, so let's do that. First of all, well, yeah, let's do that. Let's put a 2 in for it. All right? So let's put a 2 in for this. What's 1/2 of 2? It's 1. 1 minus 1 is 0. 0 cubed is 0. So 2, 0 is going to be one of my points. Okay? Now, what I like to do now, again, Abby asked this, how do I know what points I pick? I'm going to pick a point to the left of 2, since I know it's going to hit right on this axis. And let's pick a number to the right of 2. Now, what is to the left of 2? I could put in a 1, but what do you think a better number? Let's see. You could put in, well, here's your x. So there's 2. Give me a good number, an even number, to the left of 2. Let's put in a 0, and then give me an even number to the right of 2. And why do I pick an even number? Do you have to pick an even number? Nah, it's just so that you can take half of it and it comes out to a nice integer number, okay? And you don't get fractions. Does that make sense? All right, so let's pick those points and see. So what did I say, 0 and 4? All right. So put a 0. Put a 0. What's half of 0? 0. Minus 1 is negative 1. What's negative 1 cubed? It's negative 1, okay? Put a 4 in for this. Half of 4 is 2. 2 minus 1 is 1. What's 1 cubed? Positive 1, okay? Now we're getting somewhere. We're picking some good points. So let's see what it starts to look like. 2, 0 would be right here. And then you got 0, negative 1 would be about right there. And then you got what? 4, 0, 1, let's see, 1, 2, 3, 4 would look right there. Oh, so 1, thank you. 4, 1 would look right here. Does that mean it's just a straight line and I connect them? Nah, because you know what it's going to look like, right? So again, we're just sketching it. You don't have to be super, super accurate with this. If you wanted to, you could put another number in. Let's put like 6, all right, since that's an even number. Let's put 6 in for this. What's 1/2 of 6? 3 minus 1 is 2. 2 cubed is 8. So if I put a 6 in for there, I'm going to go all the way up to 8. Okay? Does that make sense? And what do you think if I put a negative 6? Where is it going to go? Down to negative 8. Okay? So again, you don't have to fill this up with a ton of numbers. You fill it up. You just put the key numbers that you think you might want to use in there. All right? And so my sketch is going to look something like this, and then something like that. And that's as easy as it is. Okay? So you don't have to put like every single point and get super accurate, especially with like fractions and things like that. Just pick some key points. This is definitely a key point. How did I know to pick that? Just because I had it multiplied by a half, right? And I thought, well, what's an easy number that I can multiply by a half? 2, right? Do you agree? And that's basically what your graph looks like right there. That's it. Okay? Let's do 33. We'll do it real quick. Actually, let me just get rid of that stuff. Get rid of this. And let's write this one. So let's see if we can do this kind of quick. This looks complicated. And I tell you what, if I told you when you first walked in the door, first day of pre-calculus, and I said, what does this graph look like? You would have probably walked out the door, wouldn't you? All right. But now you kind of have an idea what's happening here. What is that minus doing to this graph? It's going to flip it, right? It's outside the square, so it's going to flip it. First of all, what is the parent function of this graph? It's a what? It's a parabola, all right? So that's it. But what do we do with this parabola? What does the negative mean we do? It means we flip it, right? So the negative does that to it. What's the 1/2 to do to it? It expands it, okay? Makes it a little wider. Okay, that's where we're going to put a couple key points in to figure out how wide it's going to go. What is this -3 going to do to it? It's going to move it to the right 3 places. What's this -4 going to do to it? Moves it down 4 places. So where am I going to start? I'm going to start at what point? 3, -4. 1, 2, 3. 1, 2, 3, 4. That's where we're going to start, right there. Now, it's not going to go up. It's going to go what? It's going to go down. Now I just got to figure out how wide is it going to go? Well, what are you going to do? Pick some points. So where am I on the x-axis? I'm at what? 3, right? So if I put in a 3, I get -4. What's a good point to pick now? Let's just go 1 over. Okay? You could go 2 over if you wanted. Let's just go 1 over. So where is it? 1 over from 3. It's 4. And then 1 over on the other side would be what? A 2. Let's put a 4 in for this. 4 minus 3 is 1. 1 squared is 1. Okay? Actually, I don't like the... Let's put an odd number and make it work a little easier because I would have gotten a fraction there, right? So I realized that I'm like, let's do 5 and a 1. Let's put a 5 in there. 5 minus 3 is 2. Squared is 4. Half of 4 is 2. Make it negative. It's -2. -2 minus 4 is -6. So if I go over here to 5, how far down do I go? I go to -6. And then look, do I have to even do the math on the other one? Nope. If I go over 2 here, where am I going to go? That same spot, and it's going to look like a parabola. So it looks like this, and it looks something like that. Missed it a little bit, and that's your sketch. Does that help? Yeah. So knowing all these things really makes it easy to graph. Okay? What's that? Yeah, I'll let you turn this in tomorrow so you can use it to study from. So all the stuff that we went over homework the other day, right, from 5-2A or 3-2A. Make sure you look at that as well. So anything from the homeworks, okay? The quiz will only cover stuff that we did on the homework. Everybody got that, right? Okie doke.